get somebody to just read, please? Nice and loud, or 3 objectives that we're going to look at today. Thanks, Smitty. Go ahead.
Recognize examples of projectile motion in everyday life. Understand and describe the path of a projectile as a parabola.
Parabola.
A parabola, sorry.
You good?
Resolve velocities into their components to solve problems by component-specific equations. I can't see that.
Coupled or uncoupled? Coupled or uncoupled? Okay, now, the first one we kind of talked about with punting and throwing a baseball and objects moving. The second objective we talked about already also with parabolas. We'll go over those again. The third part is the important part, really. Okay, resolving the velocities in the components and solving component-specific equations, which means the x and the y direction. So let's take a look at the first slide here. First, projectile. A projectile is an object that can be modeled as a point in space. So take a look up here. If I have this Purell bottle and I have this stylus, they're both different objects, aren't they? But in physics, if I were to throw one of them at Mike, because he wasn't looking over here, even though he is, thanks Mike, or if I were to throw another one of them, they would be the same. There would be no difference. Okay? So you'd model them as a point in space. So no matter what, even if it's a rocket ship, you model it as a point in space. You just put a dot there to show that it's a projectile. Projectile motion is 2-dimensional motion. What kind of motion have we been looking at so far? Yeah, 1-dimensional motion, because an object moves either up and down or it moves left and right. We haven't been looking at things that move both ways. So we look at an object that moves up but also over, or up and over this way. Okay? Helen, ask me if you have a question. So what we're going to look at for this part is 2-dimensional motion. It could be also thought of as a free fall with initial horizontal velocity. And here's what I mean. Let's say, for the example, we have an object that's dropped this way. This is free fall, because I drop it. Now, if an object is launched this way, it's like a free fall actually, it's just pushed to the right. Because it's still being dropped and is moving down. It's not being launched up. It's being launched this way and it's going to move down. So it's like a free fall in this direction, but it's like a velocity problem in this direction. And we're going to look at an example in a moment with 2 tennis balls and see what we're talking about there.
So if you're like a cannon, like the ball would be a free fall to the x.
Provided it was shot horizontally.
Yeah.
Mm-hmm. If a cannon was angled like this and it was launched up like that, that's not free fall. That's not free fall. That's just straight up projectile motion. Okay? A cannon aimed this way that launches a cannonball horizontally, it's like a free fall. It's just like it, but it just has a push this way. Okay? It's no different than a free fall. It just has some push in the x. Now, this example here is showing a person running. And in case A, they're running horizontally. In case B, it's like they're running for a long jump. And they take a jump. Well, now they've got velocity in the x and velocity in the y, because they've jumped up into the air. So that's like a projectile. They're going to follow that parabolic path. Okay? Whoops. They're going to follow the parabolic path. So the runner would land like that. We have 2 different types of... One has air resistance, one doesn't. Clearly I already labeled here. This one does have air resistance. Okay? What does air resistance do to the projectile? What does it do to a projectile? Slows it down. Air resistance slows it down. So it's not going to reach as far, and it's not going to reach as high of a max height. Okay? Guys, you alright? Good? Okay, thank you. Alright. Let's look at an example of this. Beforehand though, let's do the example with the tennis ball. So, for the sake of being, let's use this guy. Do you mind? I'm just going to slide you back for a moment. Need these hands on the desk. Alright, so here's a question for you. If a bullet is fired out of a gun, and it's fired horizontally, so completely horizontally, so I hold the gun and I fire it, and it launches it that way. And imagine I'm in an open field where nothing is going to stop the bullet. Okay, eventually it will fall to the ground, right? Okay, eventually, but it's going to take a while. Because it's going to go far, right? You're going to shoot the bullet, it gets launched. And at the same time I shoot the bullet, I drop an object and let it hit the ground. From the exact same height the bullet is launched. So I shoot the bullet and I drop this, ready, set, go. At the exact same time. Which, the bullet or the tennis ball will hit the ground first? Tennis ball? Show me hands for tennis ball. Show me hands for bullet. Show me hands for, I don't know, or I have another suggestion. Reese.
Same.
The same. Why the same?
Because gravity will still act equally on both objects.
Yeah. Very good. The way you said that is perfect. Both of these objects are either dropped or fired horizontally. What pulls you to the ground?
Gravity.
Gravity acts the same on both objects. Now, realistically speaking, air resistance takes into account, but we've been looking at no air resistance. So gravity acts the same on both of them. So if I fire something horizontally, it's just like a free fall. It just has some push that way. So you actually calculate it the same way you would calculate the free fall time. I know VI is 0 here. I know my height is, say, 3 or 4 meters. I know acceleration due to gravity. I can find the time. Okay, I can find the time. Well, that's the exact same time you would get in the other condition. Let's take a look at this now using tennis balls. And this didn't work great in the last class. Let's see how it works here. So, what I want to do is show you that if you roll an object with some initial velocity this way, and you drop the other object from the same exact height, it'll hit the ground at the same time. Okay? And I'll see, hopefully it'll work pretty well. Let's see how it works here. So, Joyce, can you do me a favor and just let me do this? This is all I want to do. Just roll it like that so it has some velocity. And when Joyce does that, as soon as it exits the table, I'm going to let go of this one at the same time. So I'm going to have it so that it's at the exact same height, and I'm going to let go when hers reaches the table. Did you hear how close they were to hitting the table or the ground at the same time? It was like, there was a very little difference in time. If you drop it from a high enough height, this is a low height, so you're not seeing it as well. From a high enough height, if you drop something, two objects that were, say, identical, and one was moving this way and one was dropped, they will hit the ground at the exact same time. The exact same time. Just like the idea of the bullet and the object that's being dropped. It's no different whatsoever. And on the next slide, I'm going to show you what I mean. So let's take a look at this next slide here. Why isn't that going away? There we go. So this next slide, here's what it shows. It's a camera. It's a high-speed camera. First of all, anybody like photography here? Who's into photography? Okay, what does frames per second mean? Somebody explain what frames per second mean?
There's a certain number of frames per second. So like in a movie, for example, they'll shoot at 24 frames per second, which means that for every second there will be 24 still frames put together into
motion.
video.
Very good. So in every second, there's 24 like snapshots taken. Ever see those flip books where you flip through them and you see a person like running like this the whole way through? That's what that is. That's what this is too. This part here is an object that's dropped and an object that's launched only horizontally and at the exact same time from a machine. And what they've done is the following. They've taken snapshots and they've noticed that these are almost identical heights at every frame. And you'll see that there's some air resistance probably taken into account here. But these are the exact same height along the way. Okay? So an object that's fired horizontally is just like a free fall when it comes to the y direction. When it comes to the y direction. But when it comes to the x direction, they're clearly different, right? If I shoot an object that way and this one's dropped, this has no x motion at all. It just drops straight down. This one that's fired this way, it does have x motion, but the vertical motion acts analogously yeah, to the other motion of the free fall. Okay? So it acts just like a free fall. Let's take a look at an example of this. And I need to erase the... Okay, Joyce, thanks.
A bridge is 10 meters above a river. Imagine Tom Cruise jumps off the bridge to avoid a sticky situation he's gotten himself into. He jumps off of the bridge by running off the edge, so he only has jumped in the horizontal direction. If he hits the surface of the water after a horizontal displacement of 50 meters over the velocity that he has jumped.
Okay? So there's a lot going on here. Draw yourself a picture. Draw a picture of what this is. Because it'll really help. Yeah. Draw a picture of Tom Cruise jumping off a bridge into the water. Obviously, Tom Cruise always
Draw
survives.
the sticky situation.
Okay? Whatever the sticky situation is. And what I want you to do is label what you know about the diagram. You know some stuff about this diagram. So please try and label what you know.
nice distance from. Head is otherwise. Alright, thanks. No, you need to see ya.
See it through. So for a diagram for this, I might draw like a cliff, right, to represent the bridge. So maybe I'll just draw this. Here's the bridge. Here's some water. Okay. Now Tom Cruise, I should make the water blue, I guess. It's not fiery water. Tom Cruise jumps off, but Tom Cruise is a projectile. So what should I draw?
Stick figure. Oh.
A point in space. If you drew a stick figure, that's fine for now. But to make it easier on yourself, whenever you're looking at a projectile, just draw a dot. He's got some initial velocity. Next, what else do I know? The height of the bridge is 300. And what else do I know?
That he runs 50 meters.
And then he lands, 50 meters horizontally outward. Okay? Now, you do, and that's our given. So give me 1 sec, Mike, and we're going to do that. For the diagram, though, as far as marking up the geometry, that's kind of what you know. So let's go ahead and list our givens now. Okay, let's go ahead and list our givens. And what I'd like to do here is I would really like you to... What is happening? What I'd like to do is look at our x and our y direction and write down what we know. Mike, find that. So, in the x direction, what do I know? Alright, so x is clearly 50 meters by horizontal displacement. What else about the x direction?
Acceleration.
In the x direction is?
Negative. Positive. 0.
There's no air resistance, though.
Negative.
No, 0. Guys, the negative 9.81 is only in the y direction. That's gravity. Gravity pulls you down, not left and right. Gravity's not pulling me over there. It's not pulling me over there. It's keeping me on the ground right now. Okay? So that's how you remember that. Acceleration in the y. So we know that. We can write that down, right? Because you just mentioned it. What about in the y direction? What else do I know? Maria? What is it?
300 meters. Negative 300 meters.
Thank you, Camila. Why?
Because it's going down.
Object fell down, so it's negative 300 meters. So what you have here, by the way, is a triangle. Have you noticed that? See how important triangles are? It's a triangle with side lengths of 300 and then 50. That's really what this is, even though the path is going to be different. What else do I know? I know something else. What else?
The initial velocity is what we have to find.
In what, though? Tom Cruise jumps which way? Horizontally. So it's only in the x. So we're looking for VI, but in the x. VIX. What is VIY? Why? How come?
It's standing, and he's standing on the top of the bridge, so he's just gonna
Yeah, but I can stand on the top of the bridge and jump up and out and have a vertical velocity component now.
say that.
What does it say?
That he jumps horizontally.
Good. Because he jumps horizontally, it's like the tennis ball that rolled off the table. It's got no vertical drop. It's got no velocity. It's like a free fall. So this is just like a free fall. So VIY is 0 meters per second. Again, because he runs, it's like literally, imagine if you just ran right off a plank. That's what's going on here. He's running right off the bridge. And he's only running in the horizontal direction. Okay? Let's see. What else? What else could we find maybe along the way to help us? What's another variable that's not mentioned here, but it might be useful? And we've talked. What is it? Time. The time it takes to hit the water. How is the time going to apply to this problem? You're right, absolutely. What's the deal with the time?
Because it'll, wait, no, never mind, close enough.
How can the time help us?
Well, can't you plug it into, if you have the time, you can use certain
Good. So the time will help us with the equations we need. What about the time is characteristic that's really cool or really useful to help us with this problem?
It's the same for both.
Ev, awesome, very good. The time is the same for both directions. Think about it. If this person jumps and lands in the water, the time it takes in the x is the same as the time in the y. There's no difference. Just because they're traveling in 2 dimensions, it's still the same time. So time, let's write this down in big letters. Time is your linking variable. It links the directions together. So if you can find the time in one direction, what can you do? You can use it in the other. So if I can find the time in the y direction or the x, I can then write it down in the other direction to help me find more about the problem. So time is your linking variable. Now, in the x direction, there is no acceleration. Everybody agree? See, no acceleration. What is the only formula we've learned this year that does not involve acceleration? There's only one. There's only one. Nope.
Displacement.
Distance equals
Nope, nope.
velocity
Equals what?
Is it open negative?
Come on, look at your formula sheet.
Y equals
You have 4 formulas there. There's only one of them that doesn't have A in it. Which one is it? Elliot?
Velocity equals change in x over change in time.
Yeah. Remember this formula from the beginning? Velocity is... You just said velocity equals. I said what? So this is the only formula we're going to use in the x direction always, because acceleration is always 0. So what you can do is write it this way. You can write it as Vix equals x over t. Okay, because Vix, what did we talk about yesterday? The velocity in the x direction, what? What about the velocity in the x direction? It doesn't what? Why? Because there's no...
acceleration.
Yeah. Remember, the changing factor for velocity is acceleration. The only reason we speed up when we fall to the earth is because of acceleration. The only reason your car speeds up is because of acceleration. If there's no acceleration, velocity is the same throughout the whole problem. So we could just call this Vix, or you could also call it V bar. V bar meaning average or constant. It's not going to change. But here's the problem. Can I find V bar or Vix, whatever I call it? Why can't I find it? I don't have time. I've got X, but I don't have time. So what might I do?
Equations to find time.
Yeah, go to this side now. And figure out time on this side and then do what with it?
Change it over.
Yeah, slide it on over to the left. So we're solving these component-specific equations and then we're linking them, which is why I wrote coupled. Remember coupled or uncoupled? Coupled means that t is used in both. It's going to be coupled. So on the right-hand side, what equation would I use to find time? Who knows the equation in the y direction that it would use? We'll stop here, but who knows? What do you got?
Maybe like VF minus VI.
Nope, because that has no final velocity. We don't know it.
Yes, squared.
No, we don't know final velocity. The only other one.
Just figure out why can't you use the same
X equals
X equals VIT plus 1 half AC squared.
And I'm going to use a lot of subscripts, notice please. I'm going to start using subscripts. So it's y equals I'll call it VIY, t plus 1 half AT squared. This is going to drop off. You can solve for time here and then plug it in the x. We'll pick up with this on Monday. Now, so the equation that we're going to end up using on the right-hand side, if we take a look, we have y, we have initial velocity, we have acceleration, and we're looking for time. This does not involve VF. Does anyone see VF anywhere in this problem? We don't know what the impact velocity is. It's going to be some number when it hits the water. But we don't care. It's not being asked. So you can't use the VF equations. Is that clear? You can't use VF equals VI plus AT. You can't use VF squared equals VI squared plus 2AY. It's not going to work. So the only equation that's left is y equals VIT plus 1 half AT squared. Now notice what I do. Take a look down here, please. I make sure instead of writing x equals, I write y equals, because it's in the vertical direction. Then here I go ahead and I put in my VIY instead of VI. Why do I do that?
Because don't you have two different velocities?
Yeah, and I'm particularly looking in the y direction as of right now. I'm looking in the y direction for this problem, which is why I use VIY. Now, what's VIY though? 0. Why is that 0 again? Because he did what? What did he do? Yeah, it's like a free fall, but he ran off in what direction? Horizontally. He didn't run off vertically at all, only horizontally. He had no vertical component of velocity. So it's 0. So that makes this equation a lot easier, doesn't it? Because what are we solving for, people? Time. Had this not dropped off, we would have what kind of an equation? Quadratic. We'd have to use the quadratic formula or the graphing calculator. Because that term drops off, we can solve for t simply by square rooting it at the end. Okay? So at this point in time, let's write down what we have. Yeah?
If we solve this for time, would that give us the time for the y velocity?
It would give you the time for either direction. Because it's the linking variable. And what am I writing AY for? What does this little y mean? Acceleration in which direction? In the vertical direction. AX is 0, and AX is 0 because it's the acceleration in the horizontal. The acceleration in the vertical is gravity. How do I solve for time? How do I get rid of a 1/2? So that gets rid of the 1/2. How do I get rid of an A that's being multiplied? Divide by A. Remember, the y's don't cancel. That little y is a subscript. Right, isn't that what we have? So we multiply by 2, and then divide by AY. How do I get rid of the square? Take the square root. Which answer is it going to be in this case? You have plus or minus, but you know it's going to be positive, because it's what? Time. Okay? So go ahead and put the square root around here with a plus or minus. That rids us of this square term here. And that's what our solution is for time. You know what we could do? We don't even have to get a number. We could go ahead and take this expression and substitute it into the denominator over here on the left. How cool is that? Just think of the positive, take this expression, plug it in there. So what we're doing is we're coming up with the velocity that is a function of the y direction. We're not even evaluating a time in this problem. We don't even care about the time it takes. If we can plug in those variables, we've got our answer. So our final answer will look like this. That entire expression is in the denominator. Remember, AY is a subscript. So this is our answer right here. But it might be useful anyhow to calculate the time and just have a number. So you could do it either way. Okay, it does not matter. But again, we wanted to find VIX. We knew X was 50, but we didn't know time. But now we solve for time in the Y direction. We take that expression and link it into our X direction, and now we have an example of an answer for VIX. In numerically speaking, what does the time become? Did anybody solve for the time? What did you get for the numerical part of the time? Aaron? 7.8 seconds. So really we could just do VIX equals 50 over 7.8. Okay? Again, 50 was our horizontal displacement. That's this X. Aaron came out with 7.8 for T. You could just put that in here and get an answer. That's fine. So I get, it looks like 6.39 or 6.4. Is that what you got when you rounded? Okay, so go ahead and round this. And you'll get an answer for VIX of 6.4 meters per second. How do I know those are the units? What are the units of 50? 50 what? Meters. And the units of seconds, units of 7.8 are, so it's meters per second. Okay? To check your units. So with what velocity must Tom Cruise jump to maybe clear a 50-meter gap for some reason? 6.4 meters per second or greater. Right? He would clear the gap by even more. If it was like maybe it was like a barge, a boat that was underneath it, and we had to land a certain distance away. Okay? So do you see how sometimes these movies are a little bit unreasonable? Let's think about this for a second, please. 6.4 meters every second. 6.4 meters is about 20 feet. That's about the length of this room. Can I run across this room in 1 second?
Yes.
I highly doubt it. I surely highly doubt it. In 1 second. I mean, even walking quickly, it's very difficult to come close to that. Not even near. Tristan.
Maybe if you got like a running start.
Yeah, again, so that's why you see them take running starts to help. Okay, but again, 50 meters, I don't know. I think that that's a little bit tough, right? So, I don't know. Every second, it's tough to go 20 feet every second to cover a gap of 50 meters. It's a little unreasonable. James, what before you ask a question, is what would help it? What would assist and make it easier for Tom Cruise? If instead of he was, say, 300 meters above the river, if he was what? 500 meters. Because he would have more what? More time. And if he has more time, it changes the value here. So say the time was an answer of 15 seconds. Now you're taking 50 over 15 seconds, which is only about 3 meters per second. So if you jump from a higher distance, you've got more time to land, so you don't have to run as fast. And that makes more sense, doesn't it? When you have more time to land, it means your your parabola is going further and further out, so you can land even further and further out, so you don't have to run as fast. Okay, so the moral of the story, if you're going to jump and try and avoid something, jump from a higher distance. But what will happen if you jump from a higher distance then?
Splat.
Probably splat or break a leg. So don't do this at home, is the answer. James.
Alright, so, kind of unrelated, but if I were on a train and running in the same direction as the train, do I just stack the velocities on top of each other additively, or but like relative to the ground, since I'm further away, doesn't that change it slightly, or no? Or they would just add stack?
Because they're both in the exact same direction.
Okay.
They're both moving in the exact same direction, which happens to be parallel to the ground. Doesn't matter the distance from the ground, it's just that they're parallel to one another. If you take calculus, you'll learn about like scalars and vectors and cross products. We talked about scalars and vectors quickly, but you'll talk about the angle theta being 0 versus 90 at some points. And when they're 0, when they're next to each other, they're just stacked on top. Okay? Let's take a look at the next example. So example 2. Example 2 says the following. A C-130J Super Hercules plane, which is from, I think, one of the wars, World War II or I. Flying, anybody know their planes? Some people are like plane buffs at times now. Okay. Flying 500 meters above the ground, needs to drop a package to soldiers on a remote island. If the velocity of the plane is 670 kilometers an hour, which is 186 meters every second, very fast, when it drops the package, how long will it take to reach the ground level? Which is kind of like what we did a moment ago, right, from the time? Okay? It's being dropped now. How far will the package travel horizontally before it lands on the island? Horizontally. A little bit different in our variables. So let's talk about this for a moment. And I want to give you a quick demo. Here's the airplane. Here's the fighter. Here's the package. Okay? It's going, it's traveling pretty fast. It drops the package. What do you notice? Does the package fall straight down? What does it do?
It lands at an angle.
It lands at an angle. So when you drop it, it starts to fall parabolically the same way as what? The same way as what?
Same direction as the plane moving.
Yeah, the same direction as the plane is moving, and the same exact thing really is this last example. They're two completely different scenarios, but they're analogous to one another. So those of you that have been in trouble on the test with problem solving, this is where it comes into play. You need to realize here, based on the scenario, that when a plane drops an item, it's moving initially this way. So it's moving horizontally like the Tom Cruise jumping off a bridge. So this is the exact same problem, really. And I know that's difficult to understand at first, because the plane is moving horizontally at 186 meters per second, and it drops it. That's VIX. That's the initial velocity horizontally. Because if I'm in a car, remember we talked about this example, and I try to bail out of a car, it's not going to work too well, right? Because if the car is moving at 60 miles an hour, when I start rolling on the ground and getting cut up, how fast am I going? 60 miles an hour. I'll slow down, obviously, because of ground resistance or friction. But the idea is that you're moving horizontally with the car. It's the same exact example here. Okay? So for this problem, let's take a look now. We know our height is 500 meters above the ground. So let's split it up in X and Y direction and list these. It says, how far will the package travel horizontally before it lands on the island? So X is unknown. Y is how much?
300 meters.
Net down, so it's Negative 500 meters, good. What else do I know?
Acceleration of y when they interact with
Do we really have to even list it in the x anymore? It's always going to be 0, people, for the acceleration in the x, unless you're told otherwise for some other type of problem. So if you want to start not listing it, you can, or you can just simply write 0. Just to be consistent. What's next? If a problem told you that a rocket was moving in the x direction with some acceleration that was overcoming resistance, and it told you the acceleration. But for the sake of this class, I don't think I've ever had a problem that was, but I want you to know that it can exist. Okay? What else? What else?
the velocity x is 186.
Yeah. The object is dropped when the plane is moving at 186 meters per second. But it's moving horizontally because it's a plane. Okay, I should have probably written that, I guess. It says, all right, it doesn't say that, yeah. The plane is moving horizontally. What's VIY? Because it's like it's dropped, right? Remember, the object this time is literally dropped. But it's dropped from a moving frame of reference. This object is moving, and when it's dropped, it's just free fall. But because it's moving this way, it's got VIX. That's what gives it the VIX, because it's on a moving platform, and it's dropped into the air. But it's dropped vertically, so there's no throw down, there's no throw upward, it's just dropped. Okay, there's no vertical component of velocity. In this problem, it's like that. What do you mean, is it always going to be like that? You need to ask a different question. When would VIY not be 0? And the next example we're going to get into, where an object is launched at an angle. And then we'll start using our sines and cosines that we looked at with the trig stuff. Okay? Let's take a look at this. Let's keep going. What's our linking variable? So it looks like we can find time right away. And then maybe we can use that in the x direction to find x. So I want you to go ahead and do this. Go ahead, please. Go to the y direction. The same thing we did with the last problem. Find your time. It happens to be the same thing because there's, again, no VF. We will do problems with VF and it will change. Go ahead and find your time in the y direction. We'll pause the video. Record here. If we plug in and get our time, you're going to get 10.09 or 10.1 seconds. Then over here, if you need to follow along, move the t up, and that's your generic solution for x. You could then plug in 186 meters per second times 10.1 seconds. Seconds, what happens?
1876.
What happens to seconds? What am I left with? Which is what I want. I'm looking for horizontal displacement so the units make sense. Tori, what was your number? Because I rounded differently.
187.
And you use 10.1 and 186?
Is that round?
That's rounding the time to 10.1. I use 10.09. I got 187.7.9. Again, now you can see the difference, right? The rounding error it provides. And the answer is right either way. That's why the generic solution is so important. When I can see you solve generically, I can then say, oh, it's just a rounding error. Because they put the number 10.1 in. But on the test, you might have used 10.09. I really don't care there. As long as your final answer is correct and rounded, correct based on your work, and rounded to the nearest tenth, if I ask for 10th. Okay? So we need to remember that we have really two simple rules for the velocity. The velocity in the y is v sine theta, and the velocity in the x is v cosine theta. These are the rules that we came up with when we looked at trigonometry. And we came up with these when we were talking about the force applied at an angle. And we said that if you want to find the x component, just take the value of the vector and multiply by the cosine of the angle. If we want to find the y component, take the value of the vector times the sine of the angle. So today in class, what we're going to do is this. We're going to do the same exact problems we've been doing. Identical. Except instead of being fired horizontally, where all the velocity is Vx, now it's going to be fired at an angle. Okay, where there's some velocity in the x, and there's some velocity in the y. And we have to find those initial velocities by using these equations. Okay, by using those equations. What's up, Adam? So Tom Cruise strikes again in a new action movie. He has to leap from the top of one building to the top of another that's 4 meters away. After getting a running start, he jumps at an angle of 15 degrees with respect to the flat roof, while traveling at a speed of 5 meters per second. Will he make it to the other roof, which is 2.5 meters lower than the roof he's jumping from? So what are we going to do to start this to make it easy on us? Draw a diagram. So he's jumping from a high roof to a low roof. So just draw 2 rooftops like this. Okay? We did an example similar to this, but it wasn't at an angle, remember? We talked about him running off horizontally. So keep that in mind, the example that we did yesterday at the end of class. So it says that the roof is 2.5 meters lower than the other one. So that's this dimension right here. It says that the rooftops are 4 meters apart. We're also told that he jumps at an angle of 15 degrees with a velocity of 5 meters per second. That's all the information that we're given. Again, the buildings are 4 meters apart. The second building is 2.5 meters lower than the first. He jumps off the first with a velocity of 5 meters per second and at an angle of 15 degrees. Okay, it's a pretty big gap. 4 meters is like 12 feet. So imagine a gap between a building being between like me and the garbage can. That's not 12 feet. It's a pretty far gap. It's clearing. But look how fast it's going. It's Tom Cruise, right? It's running 5 meters every second. That's fast. It's almost 15 feet every second.
It's faster than me.
Okay, it's faster than Mike yesterday. Mike was only up to 3 meters per second yesterday. Okay? Yeah, Mike, you got to do a little more work there. So anyway, so Tom Cruise jumps off the building. Now, the question is, will he make it to the other roof? And the thing is that we have too much information here. What did we say yesterday? Who remembers from class when we did that quick example problem, that extra one?
You don't need the 4 meters.
Yeah, ignore the 4 meters for now, right? Remember I said that? Ignore the 4 meters. And we'll treat this problem like we don't have the 4 meters and see what x turns out to be. And if x is less than 4 meters in the end, it means that he's short of the building. If x is beyond 4 meters, it means he made the jump, he cleared it. So let's do this problem as if there's no x component of displacement. Okay? So let's go ahead and list our givens now. But now remember that we have VI's in both directions, VIY and VIX. We have both of them. What's the y value in this problem? Negative 2.5. Again, he's going down in the end. Sure, he's jumping up to start, but isn't he landing at a lower level than he started? So the y value is the change in height, which is negative 2.5 meters. X is what we're solving for. Acceleration in the y is still the same as always. There's no acceleration in the x. I'm not even going to write it. Okay? Acceleration in the x is always going to be 0, so I'm going to stop writing it for now.
Can you write it if you want?
Yeah, of course, of course.
Wait, no matter what?
Yeah, remember we said that we're assuming that there's no air resistance in the x direction and there's no like rocket booster on your back pushing you forward. So once he makes this jump, there's nothing pushing him forward besides his momentum that's carrying him. There's nothing on his back that's propelling him in the x direction with some acceleration. So acceleration in the x is 0. Now, what about the velocities? Sorry. What about the velocities? VIX and VIY, what do we have? Camila? It's not 5. Yesterday it was 5. Yesterday VIX was 5 and VIY was 0. Because Tom Cruise ran off the building horizontally. But he's not doing that anymore. So go back to your last slide and see what you have to do. Use your last slide to help you, Catherine.
Wait, with VIY?
VIY, neither of them are 5.
Time side of it.
Yeah, so Mike, give me VIX,
Is VI
which is 5.
is 5 times cosine of 15.
Good, and VIY is?
And VIY is 5 times sine of 15.
Very good, Mike. This is what I was talking about a minute ago. We no longer have only horizontal initial velocity. We have to encounter the vertical velocity, VIY, and the horizontal velocity, VIX. Now, With that said, we should really come up with numbers. And the reason I'm doing this with numbers right now is because I want you to see what the values are, so you understand what's happening here. But you could leave it like that as an expression in the future. For now, though, please type it in your calculator. What does your VIX become, and what does your VIY become? And we'll see who knows what's going on, because I'm going to ask a follow-up question. Yeah, Elliot, what do you got for VIX?
4.8.
And VIY?
1.3.
Both correct. Okay, so we don't need this line anymore. I can cross it off, right? Because I wrote down the actual numbers now. Now, Elliot, here's your follow-up question. Why is VIX bigger than VIY?
Because the angle is less than 45 degrees.
Exactly.
Wait, why do we talk about?
Once you get the numbers, 5 cosine 15 is 4.8, so I'm just replacing that line. Okay? So, Elliot's answer was VIX is bigger than VIY because it's less than 45 degrees. What is 45 degrees? Either from the lab you just noticed, or what is 45 degrees with respect to a 90-degree angle?
It's
Phillips.
it's like the maximum launch point.
Yeah, it will give you the maximum range, and at that point in time, 45 is what compared to 90? Half. So if you were at a 45-degree angle, then VIX and VIY would be the same thing. Because you're kind of like jumping both in the X and the Y direction equally.
If you're at what?
45. But think about this now, ready? Here's 45. What angle are we using? That's this, isn't it? So now, is the person jumping more vertically or more horizontally if I'm at this angle? Yeah, more horizontally. 45 is equal, vertical and horizontal. It's half right. But the minute you're below 45, you have more horizontal propulsion. So VIX must be larger. Here's another follow-up. Go ahead and square both of them and add them together. Square them individually, add them together. You better get around 5 squared. Around 5 squared. You should get around 25. So do 4.8 squared plus 1.3 squared. 24.7 or 8? 24.7. The reason you're getting around 25 is because the initial velocity was 5. What's 5 squared? Remember Pythagorean theorem? A squared plus b squared equals c squared. So that will always work to check if you got it right. Okay? So again, if you square this and square this, the sum of those squares will equal the square of the actual initial velocity of 5. Now, at this point in time, what else are we missing in this problem? We're missing one other thing right now. Reese.
The time he's in the air.
The time he's in the air for, which is clearly useful. We're going to need that. Why do I need that, Reese?
To figure out how far he's going.
Yeah, x in the x direction. The only equation we can use is VIX equals x over t. So we need time. But we can't do that in the x direction because we have 2 variables missing, right? So what do I go to?
Time is 2y.
No, be careful. It's not. Remember, that was only when VIY is 0.
Oh.
Guys, you cannot, and I knew somebody was going to say that. That's why I asked that right away. Don't use t equals square root of 2y over a here. That only worked when VIY was 0. When that part dropped off, but it's not 0 anymore. So we have to write out the entire equation, Mike. Good.
That's y equals VIY t plus 1 after t squared.
Very good, Mike. And notice now, VIYT doesn't drop off anymore. Because this is not 0, it doesn't drop off. What about the x direction? What's the equation we're going to use? That we always use in the x direction. No, not the same equation. There's only one equation we ever use in the x direction, Joyce. Yeah. V equals x over t. We obviously say VIX, but it could be just v because it's not changing. There's no acceleration. Now, in the x direction, we're missing x and t. So I can't do anything, right? There's nothing to do in the x direction. Leave it alone for now. Move over to the y direction, please. Start plugging in numbers. You're going to need room, by the way.
Wait, I have a question.
Uh-huh.
What is the sum of the value squared equal to again?
The square of the initial velocity, 5 squared.
Yeah, but what is it on the diagram? What is it?
4.8 squared plus 1.3 squared.
Yeah, but it's 25 degrees.
Where does the 25 come from?
Yeah,
What was the initial velocity given as?
the 5.
Square that.
Yeah, I know, but what is it?
It's nothing. It was just a check. We were doing a mental check. It's not needed for the problem. It's not something you're going to write as an answer ever, but it's a mental check that you're doing it right. If you square your components and sum them, you'll get the original number squared. Okay, if you square the components of x and y and sum them, you'll get the original velocity that was whatever that is squared. Comes back to the trig stuff we did last week with Pythagorean theorem. So please plug in what you know. And simplify right away. 1/2 times negative 9.81 is negative 4.905. So please plug that in. Make it easier on yourself. What kind of an equation do I have?
Can you just round it to negative 4.91?
Sure. What kind of equation do I have? Yeah, it's a quadratic equation. So please don't use the quadratic formula. Please take out your graphing calculator right now and do it that way. It's so much easier and you save so much time on the test. You can't emphasize this enough. There are many of you making mistakes in the quadratic formula. I prefer you to use the calculator for now. You will go over the quadratic formula in math anyway this year, so don't worry too much about it. Take out your graphing calculator. Put it in the right order though. Well, it really doesn't matter the order because you're not using the quadratic formula. But if we're in the right order, it would look like this. Okay, so go ahead and add 2.5 to both sides by putting a plus 2.5 and then switch the other two so you have it in decreasing order of exponents. At this point in time, when you have something set equal to 0, remember it's like you're finding the x-intercepts on the graph. So go ahead and put this in y1. Go to y1, type this equation in. Wherever you see t, use the X key on your calculator. If you're confused, either ask your neighbor or at least raise your hand. Oh, that's a typo, guys. 4.095. I'm sorry.
Which one is right?
4.905. Thanks, Ev. There's a typo up there. It should be 4.905.
Okay, so,
Yeah.
I have my calculator today, but the only thing that confuses me, like I know how to plug that in and everything, it's the right down and left down.
So you need a calculator for me to do it. Take it out.
I don't have to.
So borrow from Maria. Type it in and come back to me when you're ready. That's why you need a calculator, guys. I can't help you unless you have it.
How do you do it on a calculator?
We did it the other day. You were in class?
Yeah, I know. I can't remember.
Come on, Ev. You got to practice this stuff then. Go to y equals, type it in to start, and then I'll come back to you. Wherever you see a t, though, use x. That's what it looks like for you? So, would you let somebody borrow it, maybe?
And then you gotta plug in.
So where's your estimate for that root? Where's your estimate between where and where? Negative 1 and 0, right? So left bound, make it negative 1. Enter. Right bound, make it 0. Enter. And just enter one more time. And that gives you the first answer. And then you need to get that one also. Where's this one, you think? Between like 0 and 2, maybe? So do it again, but write the number down. Do it again, we put it between 0 and 2. Yeah, you got to find the roots though, right?
Yeah, but it's not like
Yeah. Guys, make sure you find the roots and write them down.
Alright, so I got it to here, but what do I get with you?
Second trace. Go to the 0. Guess to the left of this root. Guess. Remember you did this in class? Where is the left root approximately? Between what numbers? What integers? Is it? Zoom in a little bit. Zoom. Did you ever use this before?
Yeah, I did it in class.
Okay. Let's try it again. Now, where is that root approximately between what x values?
0 and negative 1.
Yes. So which is to the left of it? Negative 1 or 0?
Negative 1.
So type in negative 1 for your left bound. Enter. For the right bound, type in 0. Enter. It's saying search in there. Now hit enter one more time.
Okay, wait.
And that's one of your roots, Phil. Find the other one by doing the same process, but with different bounds. Using different bounds around it, okay? I'm coming, guys. I'm coming. I'll come back here in 1 second. Yeah.
What do you do after you? I totally forgot how to do this on the calculator. So I just put the entire equation.
Okay.
in my one, so then-
Second, calculate. Go down to the 0 and enter. You're going to see it's going to grab. Remember, you have to give left bound and right bound. Philip, come sit up here real quick for a moment and just help Catherine with that. Thanks, bud.
Alright, so just
Is that your left bound?
well, no, can you say that you put remember like that's
Okay. So, did you hit enter?
Yeah.
No. You didn't do your steps, Joyce. Hit steps, press second, hit trace, hit 2. You didn't do that. Second, trace, hit 2. You didn't go through your steps.
Alright.
Now it's asking for a left bound. So now you give a number to the left of it.
And then I put okay.
So what are you using to the left of it?
The -5.
Okay, and then what's to the right of it?
Can I put like 2?
No. Because if you put -5 and 2, they're both going to be in there. You can't have them both in there. You figure it out. You got it, Joyce. Figure it out.
So I got this.
Okay? So what's the question?
Wait, no. Wait. It's 86.
Yeah.
And, okay. So after you get this two answers, you just decide what is negative and positive.
Well, what is time?
Positive.
So
this
that's
one
what you...
is- Oh, that's cool.
That's your time in the Y. Now go over to the X direction. Finish the problem. Finish the problem in the X direction.
No, that's easy.
What do you use?
It's really easy. That's what I'm saying. It's not hard if you just practice it.
What do you do when you like like a root thing?
Yeah.
And then what do you do when
You
you're
break it into 2 separate equations. One with a plus, one with a minus. And do it twice.
what do you mean by that?
Rewrite this twice. Write it here, write it here. One of the times put a plus sign. One of the times put a minus sign.
I'm not sure yet.
Mike, the graphing is so much easier. It really is. Guys, listen. I'm gonna put up videos tonight under News Forum that show how to solve these. One using quadratic, one using graphing. If you're good at one of them, watch the video on the other one so you're better at graphing, please. Okay? Okay. You're not getting the other one?
I'm not getting, what's it called, point with negative.
Because it means you're not putting in the right bounds. Show me. Go through it. It's 905, by the way.
Oh, it's not over.
But don't worry about that too much. But go through the process again. Second count.
Oh, there you go.
Okay. So whatever, you'll get the one on the left already, right? How do you get that one? What are you typing in as a left bound? No, absolutely not. Think about it. Zero's got to be the left bound. Because you need to put up walls around the root you're searching for. If you put in -2 and then like +2, it doesn't know which of the roots to give you. That's why you keep getting the same one. So you need to specify a smaller interval. Okay?
Why he's not getting a 0.594 like everyone else. Like,
Because he didn't have 4.905.
Yeah.
But he said he was only getting one of the roots.
No, he asked, he's talking about, like we're getting negative 0.64, right? Yeah. It was just because he had the wrong.
Okay. So go through it, make sure you get both roots correctly, Scott. Check it out, okay? I'm going to put up the 2 answers on the board. Smitty, you got that? I know you were going to ask me a question. Did your question? Okay. Camila, go ahead. .6. So, we reject the negative solution of time, and we only use the positive solution of time of 0.86. Is that clear? We reject the negative answer that we got as one of our roots, and we only use the positive because we're looking for time. We're looking for time. We're looking for time. Okay, it's positive. Now we move that over to the x direction. So let's write 0.86 for the time in the x direction now. It's the time in both, but I don't really care about writing it up here for the y. It doesn't matter. Okay, so write 0.86 up here. You know VIX, solve for x. That's what you're looking for. Multiply by t to solve for x. And then plug in the 4.8 for VIX and the 0.86 for the time. Does anybody have a number for me that went on? 4.15. So does Tom Cruise make it? He does. Because how far was the gap? 4 meters. But he ends up landing 4.15 meters after he has fallen 2.5 meters. So he does indeed make the jump. Barely. His feet might have landed, 0.15 meters is about this long. So his feet landed this far onto the ledge in a sense. Again, we model people as points in space though. So we're not considering the fact that people have a body width and height and everything else, okay? So those problems are a little simplified because of this. Questions? Maria? What did you round it to, 0.9? If you're rounding, if you have an early estimation of the problem, I wouldn't round it as much. But again, it's up to you to round. But I would say I really wouldn't round it too much early in the problem, unless it was this, Maria. If it was 0.89, it's like, well, that's pretty much 0.9. But something like 0.85, that's kind of in between 0.8 and 0.9. So I probably wouldn't round that necessarily right away. So use your judgment in those cases. But the last answer, you can round to whatever I tell you on the test. And I say 10th on the test, so you could have written like, would it be 4.2? Was it exactly 4.15? It was 4.128? So it would be 4.1 in that case, if we rounded. Go ahead, Bobby.
Salmon often jump over waterfalls when swimming upstream to reach breeding. Starting 2 meters away from the waterfall, that is 0.5 meters high, at what minimum speed must the salmon jumping at a 32-degree angle leave the water to make it over the water?
So the salmon is about 2 meters away. So here's our salmon hanging out in the water. He's about to jump at some angle of 32 degrees. And wasn't it pink? True. Make believe for now. So we've got this salmon that's clearly pink, jumping at a 32-degree angle. It's 2 meters from the height, from the waterfall. A waterfall that's a half meter high, it's jumping up. Okay? So they hop up. And you've seen this before on the nature channels, the fish jumping out of the water. Okay? So the question is this. The statement is this. We are not trying to find out if the salmon's going to make it or not. He's going to make it. Or she's going to make it. You're told that the salmon's going to make it. The question is, what must the velocity be for it to make it? Again, we are not trying to find x or find y this time. Those are given. We're not going to blank those out like we did last problem. Now we're told that the salmon's going to make it. Find the velocity, it says. With what speed must it leave the water? So we're looking for the velocity, vi. When it says, read it carefully, the minimum speed that it must jump when it's leaving the water. So you know it's vi, it's not vf. Because it's leaving the water, the beginning of the problem. Okay? Now, with that said, we should start listing things in the x and y direction. And it's going to be a bit of a confusing problem. Okay, so you need to really bear down and make sure you're listening to this carefully. So, we have in the x direction what?
2 meters.
Good. In the y direction we have? Positive 0.5. He's jumping up. Salmon's jumping up this time. Good. Acceleration in the y we always know. Okay. Now here's the other part that we have to write down. And this is where it gets tricky. We don't know the time, so I'm not going to worry about that now. But we do know something about VIX and VIY. What is the definition of VIX, according to that slide 2 slides ago? VIX is defined as?
It would be 2 times cosine 32 degrees.
Close, not 2. 2 is x, right? Just give me the definition. It's the initial velocity times the cosine of the angle. Do we have the initial velocity though? Isn't that what we're looking for? So let's call that VI and say that, well, that's times cosine 32. Again, the definition of VIX is VI cosine theta. We have theta, so at least fill that part in. We don't have VI. In the y direction, VI sine 32. Okay? So even though it looks like in this problem we don't have enough information, we actually do. What variable are we really looking for in this problem? Yeah, so what is that variable? Initial velocity, so it's VI. We're not looking for VIX. We're not looking for VIY. They're not even given. We're specifically looking for VI, which appears on both sides, doesn't it? It appears on both sides. What else appears on both sides? Time. Time always does. And here's the issue with this problem. Take a look, please. How many unknown variables are on the right side here, in the y direction? How many unknown variables are on this side? Not 3? 2? Joyce, which 2? VI and time are unknown. Remember, we're not using this here. We're using the VI part. So VI and T are unknown on the right-hand side. What about over here? What's unknown? The same 2 variables. VI is unknown and time is unknown. Okay, we're not worried about this right now again, because we're looking for VI. So we have 2 unknown variables on each side. So we can't specifically solve one side and then move it over, because there's 2 missing variables. You can't solve an equation with 2 missing variables. So we need to write both of our equations out and see if we can use some sort of method called substitution to solve them simultaneously. Okay, let's take a look at what we've got. So let's write down our equations. Our generic equations for motion are this. Alright, that's our first one. And our equation of motion over here is this. Again, on the right-hand side, t appears twice. VIY is really VI sine 32, so we have 2 variables. On the left-hand side, VIX is really VI cos 32. So VI is missing here, and time is missing here. So we still can't solve for things. But what do you know? Time is on both sides, and so is VI. Which one are we looking for again? VI. So do we really care about the time? So here's what you do, and write this note down. Solve for the variable you don't care about, or you don't want, on one side. So in this case, we said we don't care about time, right? So let's go ahead and solve for time over on this left-hand side here. Because you clearly can't solve for time over here, right? Everybody see this? In the y direction, you cannot solve for time. So don't try it over here. Solve for time on the left-hand side. You get time equals x over VIX. Agreed? You remember you just flip-flop these? Okay, just switch these 2 directionals here. Next, we know what VIX is, we know what x is. It might be given as a variable, but we know what it is. So I can plug in. What does this become? What over what? Plug in the numbers, actually.
2 over VI cosine 32.
Good, 2 over VI cos 32. So we're literally plugging in this here, in for this here. And the 2 meters for x, in for the 2 meters. So that's what the time equals. Is that a number? It's clearly not a number, because we don't know what VI is. But we can take this expression and plug it in for time in the other equation in both spots, using substitution method. Substitution method tells me if 2 things are equal to each other, I can plug one of them into the other. Well, on the x direction, this is time. So go ahead and plug it in the y direction in all those variables. And it's going to be a little messy here. I'm going to write it below this because I'm going to run out of room. I'm going to write this all down at the bottom here. So I'm going to take this expression and plug it in here and plug it in over here and write out what my new equation looks like. You can plug in all those other numbers if you want to, by the way. Okay, if it makes it more useful for you, if you want to do this first, it might make it easier for some people. Plug in your values. Y is 0.5. VIY is going to be VI sine 32 times t plus or minus 4.905 t squared. Okay, so I can do that first if it makes it easier, and then plug in for the time, just to make it easier on yourself. Okay, we're given the y value of 1/2. We're given that VIY is VI sine 32. That goes in here. Okay, again, that gets plugged in. We don't know the time. Let's plug in for the time. Let's see what we get now. We get 0.5 equals VI sine 32, which is the first part, times time, but time is this big expression, minus 4.905 times the time, which is that big expression again, squared. See how much math you really need in physics now? It's really coming to see that you're using substitution also here. So we plugged in for time our solution from the x direction into the y direction, giving us this massive equation, which looks very complicated. It's not. Okay, just follow steps, one step at a time. This is not a difficult equation to solve, actually. The reason being, what happens to your VIs in the first part? Yeah. So the only VI that's left over is down here now. Okay? So we don't have to worry too much about this problem. It's not as difficult as it looks. So let's go ahead and come up with a number. Now, anybody know from math class, what does sine 32 over cosine 32 mean? What is sine over cosine defined as? Who remembers? You may have learned this from the Starks already in the last few weeks. It's not the reciprocal. They're not complementary. Sine over cosine is defined as the tangent function. So you could replace this with tangent 32, or you could just come up with the decimal values and do the math. So here's what I would write if it were me. Okay? I would write this. And it gets rid of these two right here. If you just put tan 32, it gets rid of sine over cosine. It's the same thing. And then times the 2 that's there still. Minus 4.905 quantity squared.
Wait, how does the how does tan 32
come about from two different functions? It's the definition of tangent, by definition. Tangent is defined as the opposite over the adjacent. Well, the opposite is technically the sine, and the adjacent is technically the cosine. So it's sine over cosine always. So if you didn't want to do that though, folks, you can type in sine 32, cosine 32, and do the math, you get the same answer. Okay? At this point in time, here's what I want you to do. Come up with a number wherever you see the cosines and sines and try and simplify things. So what is tan 32, enter, times 2? 1.24. Is that rounded correctly?
Yeah.
Minus 4.905. Now I'm going to leave the square on the outside still of the whole thing. Okay, I'm still going to leave the square out there. And I did it differently in the other class. I'll explain why I'm doing it this way in this class. What is cosine 32? Decimal. Give me 2 or 3 spots at least for the cosine 32 that's going to go in that denominator there. Somebody, come on. You all have calculators. Thank you, Philip. 0.848, and I'm going to put VI after it. Doesn't matter. Again, cos 32 is 0.848, so it's 0.848 times VI. Now all you need to do is solve this. Subtract the 1.24. Do not combine these terms. 4.905 is attached to the parentheses. You can't do anything. So subtract 1.24 from both sides. You should get negative 0.74. Agreed? Subtract 1.24, move it over here pretty much, giving you this, carrying down everything else. Okay? So nothing changes in the right portion. All you're doing is taking away the 1.24. Now divide by 4.905, please. This is why the decimals are actually important. Remember what I was saying before? So you want to keep a few decimals because you're going to be doing all this math. So divide by the 4.905 on both sides. What do you get when you do 0.74 over 4.905? They're both negative, so they're going to cancel. What do you got? Give me 3 decimals. Okay, so again, you're dividing by negative 4.905 on both sides.
Why are you doing that instead of adding?
So we can get the square part by itself. Because how can we get rid of the square now? Take the square root?
Yes,
Square root. So square root both sides now. Square root of 0.151. What do you get from that?
0.389.
And that's equal to 2 over 0.848 VI. And now at this point in time, you can flip-flop like we've been doing. You could take this expression and move it up here and flip them. Okay? And solve for your VI by dividing by the 0.848. If you want to, you could simply, instead of flipping the entire thing,
It actually get negative, 0.151.
0.74 over 4.905. Divide by 4.905 because it's multiplying over here. Okay, actually I would just switch these two here. That's what I would really do. Flip those two around. Okay, so you end up with an answer of 2 over the quantity 0.848 times 0.389. Again, flip those two locations. You can always do that. Always, always, always. Did anybody get a number? 06, so 6.1 meters per second. Perfect. Okay, and I did it a different way in the notes. If you want to take a look at the notes, you can see different interpretations of these two. Tonight, we're going to finish up the last problem tomorrow for 3-3. But tonight, try and finish up all your 3-3 homework from this section. So tomorrow night, you can focus on the problem set from 3-3. Okay, finish up the homework from this tonight. The devil was shot out of a cannon at 45 degrees to the horizontal with an initial speed of 25 meters per second. Now, a net is positioned at a vertical distance of 11 meters from the cannon. So it's somewhere above the cannon at 11 meters. At what location to the right of the cannon should the net be placed in order to catch the daredevil? What's a daredevil? Yeah, like a stunt rider or a stunt person at maybe a circus or like some sort of festival. Evel Knievel would be an example. So we've got this. Let's draw our person leaving the ground at a 45-degree angle. And we put a dot to represent the daredevil. We know the velocity of the daredevil is 25 meters per second initially. And we have our angle. So already we can see how we're going to have X and Y components. We know that the net is positioned 11 meters vertically above the cannon. But obviously it's not right above the cannon. It's somewhere out here. And that's what we're trying to figure out. At what location to the right of the cannon? So we're trying to figure out, what is this X? Here's the net right here. Okay? And we want the stunt rider to land in the net at the end of this stunt or whatever he or she is doing. So we have to determine what X is. We're told that Y is 11 meters. That's my diagram right now. And the question is to figure out how far over the net is to the right of the daredevil of where she is launched. Okay? So on your own, please start by just writing down your givens. Make up your X and Y columns like we've done before. Some of your drawings are amazing, by the way, because you guys zoom in and make them so detailed. I look really good with them all the time. I'm serious, yeah. All the time. I was looking at the two of you. So again, we're trying to figure out what the value of X is, but let's start by writing down our givens in this problem. Let's start by writing down our givens. By the way, I'm going to do it when I do the lab problem. It will definitely help you with one of your problem set problems. So keep that in mind when we're going over one of the lab problems we're going to do. Now, who can tell me some of the givens in the X?
What is that circle?
This?
Yeah.
The net.
Oh.
He's got to like land in it, okay? What do I know in the X direction? In the X direction, Reese, give me something.
AX is 0 and VIX is 25.
Okay, VIX is not 25. What is VIX? Somebody help Reese out.
25 times cosine of 45.
Good. Remember, people, it's fired at an angle, therefore, you have to use the components. If that's what VIX is, what is VIY?
25 sine, 45.
Yeah, same thing with a sine. Very good. What's AY?
Negative 9.
What else do we know?
Y is 11 meters.
Yeah, and it's not negative 11, it's definitely positive 11, because the Daredevil is starting on the ground and ending in this net that is 11 meters above ground. So it's definitely a positive 11. What do I want to find? X.
And T.
Yeah, and I'm realizing now that in the X direction, I need to find T in order to use my standard equation. Here's my standard equation in the X direction. And clearly, if you want to find X, you need VIX, which we have, but you also need T. So we need T in this problem. Okay? So, how would I go about solving this problem if we want to find X? What do I do first? What do I do first, Mike?
Well, since the y only has one variable missing, you can set up the equation y equals DIY t plus 1 and
Good, Mike. Very good memory. Again, as you use this equation more and more, you will memorize it inherently. And notice Mike says VIY with the y subscript. Make sure you do that. Now, the problem is this. It's just going to be difficult to find t. How come? What kind of an equation does this become? Quadratic in nature. Very good. Quadratic. So let's plug in on the y side. What does 25 sine of 45 come out to be for the VIY? Give me a number. And I like the 2 decimals. That's good enough for now. We don't want to round too much there. And it's going to be minus 4.905 t squared. So all you need to do now is move the 11 over by subtracting it, put it in your calculator, and find your 2 x-intercepts. All you need to do now is solve the quadratic by looking for your x-intercepts on the graph of the calculator. Okay? So it's going to look like this. And we're going to take that expression here and plug it into y1. Plug it into y1. Go ahead and find out what your 2 times will be here. Again, there's going to be 2 times. And we want to talk about this in a minute because they're both going to end up being positive. I'll give you that hint right now. You're going to get 2 positive times, and we want to discuss what their significances are. Okay? Anyone else have a hard copy of homework for me?
I do, but I don't have the last one.
Say again, Mike?
With like, instead of like doing it all out, you can just like graph it.
Mm-hmm.
Do you just like enter 0 equals negative, like that whole thing?
You enter just this, Mike. Ignore the 0. Everything to the right side, but then a y1. But remember, where you see a t, what should you put?
After it's
graph, I don't understand what you mean by find the border.
Find the x-intercepts. Let me see your graph.
Wait, oh, got it.
You need to zoom in if you can't see. Guys, if you cannot see where it's between, you have to zoom in. Hit zoom from the top and hit zoom in. Yes. Now maybe you can see a little better, right? Guys, use the zoom function in the top middle to resize your window. You really need to go home, and this is going to sound really lame and nerdy, but play with your calculator for like an hour and learn the functions. Learn the window settings, learn the zoom function, learn the zero function, that stuff that like, I'm not joking with me, but in like 7th grade, like I knew how to do that stuff with these. Okay, you need to really make sure you go home and practice this. Clearly not right, or zoom is way off. Zoom 6 on this. I'm going to give you the normal 10, 10, 10, 10. Now, it's tough to see where those are, so you don't want to zoom in, so zoom, and go zoom in.
Oh, no, there's X.
This is your part.
Yeah, clearly we want to be over here, though, don't we? Yeah. So we can't go where else, go to window. And change your X max, to go a little bigger. That's X min.
Oh.
So maybe like 4 or 5. So you just extended the right axis a little bit there. Now you can see where it's between. It's like between 0 and 1. And this one is between 2 and 3, right? So now when you go through this whole process, starting now, minus 0, go down and enter. You have to pick a number on the left. It's going to say left now, so pick a number on the left of this. Right there. Now pick a number on the right of this intersection, but without going past that.
Well, the zeros over here.
The right of this intersection. Pick a number, down. This is 0, this is 1, this is 2, this is 3, this is 4, this is 5. What one is over here? How that makes sense? Not past this line. To the right of this line, this intersection, without passing this one. Yeah, because it's just right of that. Yeah? So now just enter. Saying guess. I'm saying. Go locate it for you.
That is the value of X.
For T. Time. And you need to find the other one also. Same process. Yep. That's what we're going to talk about. You can try and figure it out yourself. Find out your 2 X's. Go ahead and solve for X twice on the left hand side. Go ahead. Guys, once you get time, you can move over to the X direction and solve the problem.
When I did it, graph for T is 8.
You must not place it there.
That's on the equation.
Because you the equal sign is not highlighted. You need to turn it off. Turn off the line. When the equal sign is highlighted,
I know that.
you must have been entering the equal sign by accident to turn it off.
Yeah.
Not registered.
I don't know what to do after.
Okay. So what are you trying to figure out first off? What's your goal? What are you looking for? Good. But on the graph, what are you looking for? Yeah. You focus on that. You're looking for these intersections here and here. So to find those, you can press second on the calculator. You want to find the zeros. So go down to that, hit enter. Now, what this is telling you is to guess the number on the left of this one.
Any number?
Something that's on the graph, anywhere.
Negative.
Okay.
So
Type it. Enter. Now it's saying pick a number on the right of this, but don't go past this one. Okay? And now hit enter. It's searching between -1 and 2 for that answer and finds it for you. Now you do the same as the other one. But again, you can't have your left and right bound around both of the roots. Also won't know which one to pick. So do it again for the next one. And make sure your left bound is somewhere inside here, and your right bound is somewhere out here.
how do you do that? Like, I don't know where you drop with this.
There's your time. That's your answer. Every one of your times. That's one of your solutions to this equation. And then you're going to find the other solution by finding the other root, or the other
you get two positive numbers?
Yeah.
Yeah, so you just pick the one that's more
Oh, which one's more sensitive? Why do you find the x twice? Why? Why is that more sensitive? What's your argument?
because if you can shut out at, wait, what was that? 25?
Guys, find both answers for x. Even though you know one of them's only right, use both times to find both x's. And then you make more sensitive.
So then it's
It is left the outside, but it's projectile. So if you get two answers for two x, it's the end of 11 choice.
I just like shooting into it.
Well, we don't know. We don't know. If you only got one answer, then it'll be like you're shooting into it. One answer, one answer, one answer. No, I'd rather it's done now. Jackson Heights machine, I find the time of flight, I'm cutting it in half, and then plugging it into the y equation, finding y. No. They're saying where should be located in the line of the rocket. Okay, hold on. You did what you needed to, so hold on 1 second. People are way behind you. I need to have up. You're good where you are. Think about what your answers are. Wait a moment.
I put a -1 and 2.
It says guess. Guess. Hey. Yeah, you got, after you put your left down and your right down, it says guess. Remember I said hit enter again. And that's one of your times. That's the one you got. Now you can find the one on the right.
I got the same answer, but I'm at the. You're just gonna play the.
Oh, it's b squared. You're not squaring b. Instead of bracket, it's 17.68. It should be b squared over 46. So the negative here, 17.68 squared is a very large quadratic number. It will be bigger than that negative number. Okay? Yeah. What you found is. Because you're not pressing the right command. What are you doing after you grab? Are you pressing anything or just sitting there?
Yeah, zoom sitting.
Okay.
And I go to trace.
No?
Oh,
Second trace. And then go to the zero function. Okay? Remember, Scott, you're finding what's called the zeros of the function. Those are the x-intercepts. So you're never going to be able to do that unless you actually press that keystroke. Okay? Mike?
For the quadratic formula, when the x equals, would x be 0?
No, x is t. T equals. X is your unknown variable.
Oh.
So it's really t equals. You're solving for t minus. Okay?
Why do you have to do it to both sides? Did you say you have to do it to both sides?
What?
Why do you have to do it to both sides?
Both sides of what?
I did the one I did with you, and then you said do it again yourself.
Because there's two roots. It crosses the axis twice.
But isn't this finding time?
Yeah, time could occur twice. Just trust me and do that, and we'll talk about it. Find the other one, the same way you found the first one.
Wait, Mr. House, how remember yesterday when you said you recommend us do the calculus instead of the quadratic formula? Like how, not bad, but
You told me it has to
It's more work. It will take you 4 times as long in the test. At least. To do that way as opposed to the graphic. So do you need to come to office hours, Mike, or come see me at some point? You still don't get it.
I get the quadratic.
So what don't you get about the calculator though? I've gone over it 4 or 5 times now. I've gone around and showed people.
It's just like weird. It's like you're like checking.
It's a matter of practicing. You have to practice more. That's all it comes down to. Remember the quiz I gave you?
Yeah.
Change those numbers, A, B, and C, and do a bunch of problems again. And practice, and go home and do that. That's why I said, you guys, all of you, not just you, do not know how to use your calculators at all. And unfortunately, this is physics, not math. You can't spend a period teaching all the functions of the calculator. That's why I showed you the zeros. If you need more help, please come see me. Okay? Guys, these are the 2 answers you get for time. Okay? If you're having trouble with this still, you need to come see me. Or just go to YouTube and type in finding the x-intercepts on a graphing calculator. There's like 37,000 videos that describe it. So there's absolutely no reason, listen, there's absolutely no reason you should be asking me how to do this still. It's been a week now. You've had an opportunity for 2 of these quizzes on it. Please, learn. Learn. Don't be lazy. That's just being lazy when you have resources available and you're not using them. You have 2 times. There's a reason you have 2 times here. And some of you have picked up on it already. When you use these 2 times over in the x side of the equation, you can solve for x twice. So the generic solution for x is this. Okay, that's the generic solution for x. And we know that VIX is given in the problem. What does VIX turn out to be? Elliot, what was the number for VIX?
It's the same thing as VIY.
Because it's what angle?
It's 45 degrees.
Good. And I was hoping somebody would pick up on that. VIY, if you remember, was 17.68. Well, VIX is also going to be 17.68. Now that's times the time. But the question becomes, what is the time? Which one are we going to use? So if you don't know, just go ahead and use them both. Do the problem twice. Solve for x 2 different times using the first time of 0.8 seconds and the second time of 2.8 seconds. You will get 2 answers. They will look like the following. X is 14.1 meters and x is 49.7 meters. Has anyone been able to figure out the significance of this? I know I told a few of you, but that I didn't tell the answer maybe? Does anyone have a guess as to why we're getting 2 values for x? All right, those that I did discuss it with, does one of you want to explain? Go ahead, Phil.
Sure, because it's going, we're not looking for what distance is the maximum height, we're looking like where the parabola ends on both sides, and since they're both positive, it ends like...
Close. Be careful. This is 0 height, right? Take a look. Where's 11? Philip, 11's like right here, right?
Yeah.
So, how many times is this stunt devil going to hit a height of 11?
Twice.
Here
So you're looking for both
and here. Do you see what I'm saying now? Take a look at the board, please. After a distance of x of 14 meters, after a distance of 49.7 meters, the stunt devil is following a parabolic motion. That's why it's a projectile. So he's going to hit a height of 11 meters on the way up. That's the 0.8 seconds on the way up. And the 0.8 seconds corresponds to 14 meters. You should really all be looking up here. Okay? I know some of you are taking notes, and that's fine, but I see others just looking at their iPad. I don't know. If you're not doing notes, please stop what you're doing. So after 14.1 meters, which is a time of 0.8 seconds, the stunt devil will hit 11 meters, but on the way up. On the way down, again, he'll hit 11 meters, or she'll hit 11 meters, and that'll be at 49.7 meters along the x-axis, which is corresponding to 2.8 seconds. So that's why you got 2 answers for time here, and that's why you couldn't necessarily rule them out right away. But now that we looked at the problem, is the stunt devil going to land if he's going up? It doesn't make much sense, right? So the answer is actually 49.7 meters. Your final answer is 49.7 meters. That's the distance the net should be placed to the right of the stunt devil. Sure, technically you could put a net at the earlier one and he would hit it and stop, but the question was when he's landing in the net. So we would traditionally choose the one that makes more sense. Okay? Alright, again, you could have a net at the beginning one, but it wouldn't make much sense. Again, if you have problems with the right-hand side, with solving for t, please take a look or come in for extra help or come in during a free period. It only takes like 5 minutes to go through on your calculator. But if you're really having trouble, you should write down steps. A few people have done that and are doing really well with this. Joyce, you wrote down 20 steps, was it? To go through? 14. I mean, if somebody wonders how to write these down, maybe you can ask Joyce and say, hey Joyce, can you send me those steps you wrote down? Because it's on her Notability. She could just PDF and send it to you, right? So feel free to share that with other people if it helps them. Okay? So maybe you guys can ask her nicely. All right. What I want to do now